Hi, 7th grade. Welcome to your first lesson of Topic 5, Write Two-Step Equations. By the end of the lesson, I want you to be able to say, I can represent a problem with a two-step equation. Let's explore it. Marley collects golf balls. His neighbor Tucker collects 3 more than twice as many golf balls as Marley. Part A. How can you use the table to represent the number of golf balls in Marley's collection, M, and the number of golf balls in Tucker's collection? Part B, how can you use an algebraic expression to represent the number of golf balls in Tucker's collection? So first I'll set up a table for you. We've got Marley's and we've got Tucker's. So let's say Marley collects 0, 1, 2. Using what you know about the relationship between Tucker and Marley, I want you to try and fill out the table. And then part B, I want you to write algebraic expression to represent Tucker. So T equals, and we don't know how many Marley makes, but we can use M for that. Okay, so hopefully you recognize that Tucker collects 3 more than twice as many as Marley. So we got to take how many Marley makes, so 0, multiply that by 2, that's still 0, and add 3, so that would be 3. Then if Marley gets 1, we multiply that by 2, because twice as many, and then add 3, that would be 5. And lastly, 2 times 2 is 4, plus 3 is 7. So basically the whole time what we did was we took twice the amount Marley made, or collected, and then added 3. It's very important to pay attention to these key words. 3 more, which means we're adding 3. And twice, which means we're multiplying by 2. How do the terms of the expression you wrote in part B relate to the values in the table? If you were to plug values in for M, you would get out values for T. So we could even use the expression, the equation, to fill out the table. Ready? Example 1, write a two-step equation to represent a situation. What equation can be used to represent the number of golf balls in Marley's and Tucker's collections? So we have Marley's collection, and then we have Tucker's collection. Still the same thing. Tucker has 3 more than twice Marley's. But it tells us that Tucker has 159. Use a bar diagram to represent the situation. So we've got Tucker's collection, and we know that's twice M plus 3. So that's why they have the 2 M's and the 3. So we know T equals 159. Remember, T equals 2M plus 3. Now that we know what Tucker has, we can put 159 in for T. So this equation can be used to represent Marley's and Tucker's golf ball collections. So you could actually solve this to find out how much Marley has, but that's going to be next lesson. Try it. Cole buys a new laptop for $355. He makes a down payment of $50 and pays the rest in 6 equal monthly payments P. What equation represents the relationship between the cost of the laptop and Cole's payments? Well, let's do the bar diagram first. How much was the cost of the laptop? $335. And how much was his down payment? $50. And we can see the 6 P's, and they're all the same size because there are 6 equal monthly payments. So the cost is equal to the down payment plus 6 times the monthly payment. So the total cost is $335, which equals 50 plus 6 times P. Writing that all together, 335 equals 50 plus 6P. Where are both multiplication and addition used in the equation that represents Cole's monthly payments? Because you multiply the monthly and add the down payment. Because the down payment only happens once, where the monthly happens, it's like repeated addition, so we know we can multiply. All right, example number 2. Write more two-step equations. A baseball weighs 25.75 ounces less than a bat. What does less than mean? Subtract. Write an equation to represent the relationship between the weights of the baseball and the bat in terms of the weight of the box, W. So we know the box contains 50 bats and weighs W ounces, and one baseball weighs 5.25 ounces. So we're going to take the weight of one baseball, which equals the weight of one bat minus the difference in the weights. So here we have the weight of one baseball. Then we don't know what the weight of the box is. Since we don't know the weight of the box, we just use a W. But we know there's 50 bats in the box. So we have to divide that weight by 50 to find out what one bat is. And then subtract 25.75, which is the difference. So here's our equation. And we will work on solving next class. Try it. Marcia and Tamara are running a race. Marcia runs 4 kilometers. Tamara has completed 3/4 of the race and is 2.5 kilometers ahead of Marcia. Write an equation that represents the relationship between the distances each girl runs. Let K represent the total length of the race in kilometers. So we know Marcia has run 4 kilometers. And Tamara has run 3/4 of the race and is 2.5 kilometers ahead of Marcia. So she's ran 2.5 kilometers ahead of Marcia. So if we were to take Marcia's, we would know it was equal to, this is backwards. Tamara has finished 3/4 kilometers and she is 2.5 kilometers, or she's finished 3/4 of the race and it's 2.5 kilometers ahead of Marcia. So if we take Marcia's, going to be equal to, Marcia is 4. That's how far she's ran. And she is subtracting 2.5. Okay. Example 3. Interpret quantities and operations in equations. Claire bought 8 tickets for a total cost of $104. She had used a coupon code to get $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation? So $3 discount times the difference of 8 tickets and the cost per ticket. So we have that total cost is 104. X minus 8 times 3. That doesn't work. We're subtracting the $3 off. So then 8x minus 3, well, it's $3 off each ticket. So that doesn't work. So then x minus 3, that accounts for how much you get off each ticket. We bought 8 of them, so this one is the correct answer. At the mall, Claire buys a hat that is 60% off. Remember 60%, we do 60 divided by 100, which gives me 0.6. And socks that are reduced to $5.49. She spends a total of $9.49. Let X represent the cost of the hat. Which of the following equations correctly represents Claire's shopping trip? So we don't know how much the hat is, but we know it's H. And she buys it that it's 60% off. So it's H minus 0.6H plus the socks that she bought that were $5.49, equaling a total of $9.49. This doesn't match any of our equations, but we can combine like terms. We have a 1H minus a 0.6H. That's 0.4H plus 5.49 equals 9.49. And there we have it. All right, 7th grade, let's say it. I can represent a problem with a two-step equation. Have a great day.